Good morning all of you. The last video we discussed something about the carbon monoxide. That's the reactions, properties, physical properties, some chemical properties, preparation. And this class we are going to discuss about the reactions of carbon monoxide structure and its uses. Okay, anyhow, today our learning objectives. What is the learning objective? To learn about reaction, structure and uses of carbon monoxide. To learn about reaction, structure and uses of carbon monoxide. To learn about production, preparation, properties, reactions and uses of carbon dioxide. These are the today learning objectives. Here, the carbon monoxide preparation. The reactions of carbon monoxide. One is Fischer-Tropsch synthesis. Fischer-Tropsch reactions. Here, the reactions between carbon monoxide with saturated and unsaturated hydrocarbon forming. Reactions between carbon monoxide and hydrogen in the presence of certain catalyst, metal catalyst, and we are applying certain pressure, we get a saturated and unsaturated hydrocarbons. This reaction is called Fischer-Tropsch synthesis. That means the reactions of carbon monoxide with hydrogen. The reactions between carbon monoxide with hydrogen and the pressure is very less. There is about 50 and with the metal catalyst is at 500 to 700 Kelvin to yield saturated and unsaturated hydrocarbons. Here, carbon monoxide, we are taking carbon monoxide plus 2n plus 1 is just a number of moles. Hydrogen. Just on carbon monoxide, n moles of carbon monoxide, 2n plus 1 H2. N moles of carbon monoxide, 2n plus 1 H2, and the pressure is less than 50 atmospheric pressure. 50 atmospheric pressure. It is very less than 50 atmospheric pressure, and also the metal catalyst at 500 to 700 Kelvin. 500 to 700 Kelvin. Here, n moles of carbon monoxide, 2n plus 1 H2. Here applying less atmospheric pressure, that is 50, and metal catalyst with the temperature is 500 to 700 Kelvin. We get saturated alkane and unsaturated alkene. Can you say what is the formula for saturated hydrocarbon? Cn H2n, Cn H2n plus 2. Cn H2n plus 2 plus n moles of water. This is the saturated hydrocarbon formula. Alkane. We can say alkane. Alkane general formula Cn H2n plus 2 with n moles of water. Second reaction, n moles of carbon monoxide with n plus 2NH2. The number of moles is 2NH2. the same atmospheric pressure. That means very less than 50 atmospheric pressure. 50 atmospheric pressure and metal catalyst about 500 to 700 Kelvin. Here the metal catalyst we are using, we get CnH2n plus n molecules of H2O. This is the formula for alkenes, CnH2n. Alkane, CnH2n plus 2, CnH2n. These are two hydrocarbon. We get saturated. Why we are saying saturated? Here saturated alkane means having single bond. The compound having single bond. For example, methane, propane, we are saying single bond. Here unsaturated having double bond. Unsaturated hydrocarbon, alkene. These reactions we call as Fischer-Tropsch reactions. And also, carbon monoxide forms numerous complex compounds with the transition metal. One of the important point, it forms numerous complex compound with the transition metal. Can you say what is transition metal? We are saying D block elements. The D block elements are called as transition metal. For example, gold, silver, copper, etc. are the D block element, transition element. Okay, here having one of the complex is formed with the transition element. For example, nickel. Next one, iron Fe, and chromium, Cr. These are the examples carrying excellent or textbook. Nickel combines with the carbon monoxide. We get NiCO 4 times. This is one of the complex. And also Fe, iron forming one complex, FeCO 5 times, one of the complex. Chromium forming one complex, CrCO 6 times. These are the complex. Numerous complex compound. What are the 3 examples? Complex formation with the nickel and carbon monoxide. Complex formed by the iron and carbon monoxide. Complex formed by the chromium and carbon monoxide. How can you say the name? Here we can say, first say the metal name. What is the metal name here? Nickel. How much carbon monoxide they are having? 4. So we can say nickel tetracarbonyl. Okay. What's the name of this compound? Iron pentacarbonyl. 5 carbon monoxide having, so iron pentacarbonyl. Here chromium hexacarbonyl. These are the examples. Okay. Have it out? No. Next one, structure of carbon monoxide. Structure of carbon monoxide. Structure of carbon monoxide. The first point is it has a linear structure. What's the meaning of linear? The compounds are occupied on a straight line, linear structure. 3 electron pairs are shared between carbon and oxygen. 3 electron pair shared between carbon and oxygen. Carbon and oxygen having 3 electron pairs sharing. And one more point. It is explained by molecular orbital theory. It is explained by molecular orbital Next one, CO bond distance is equal to, that is carbon oxygen bond distance. This is also very, very important point. 1.128 Armstrong unit. Bond distance, carbon oxygen bond distance is 1.128 Armstrong unit. How can you draw this structure? First of all, you should be take carbon monoxide, means the two element you should be take two element. First one is carbon, one bond, oxygen. All of you know about that atomic number of carbon is equal to 6. Atomic number of oxygen is equal to 8. The first shell carbon have 2 electrons. That's a K shell 2 electron. The second shell is 4 electrons. And the oxygen having first shell 2 electrons, second shell 6 electrons. Okay? So first one, we are accommodating the 6 electron to oxygen. 1, 2, 3, 4, 5, 6. Here carbon having, already I told you, carbon having outermost 4 electrons. Here 1 electron, 2 electron, remaining 3, 4. So carbon donated electron to oxygen. So we are giving minus plus charge, here having minus charge. Carbon donate an electron to oxygen, so carbon having positive charge, nitrogen gain an electron, oxygen gain an electron to get negative charge. This is the first structure. Another one structure, here this electron should be paired here. Okay, so what? The double bond is converted into single bond is converted into double bond. Okay. Oxygen 1, 2, 3, 4. Okay. Carbon already having 2 electrons. Can you draw? Next one. This will be again attached here. So double bond is converted into triple bond. Carbon, triple bond, oxygen. Am I right? Here carbon gain an electron, so negative. You donate an electron, so get positive. This is a structure. Can you draw? So here carbon monoxide having which is structure? Linear structure. Here having 3 electron pairs shared between carbon and oxygen. 3 electrons. 3 electrons are shared between one electron. Finally having 1 electron, 2 electron, 3 electron. 3 electrons are shared between carbon and oxygen. It was explained by molecular orbital theory, and the bond distance is about 1.128 Armstrong unit. This is the structure. Next one, our learning objectives. What is the second learning objective? To learn about the preparation properties and uses of carbon dioxide. Am I right? Carbon dioxide. About carbon dioxide occur in nature in free state. It occur in nature in free state. And also combined state. It occurs in nature in free state as well as in combined state. It occurs in rocks as calcium carbonate and magnesium carbonate. It occurs in rocks as calcium carbonate and magnesium carbonate. These are the occurrence of carbon dioxide. Then about the preparation of carbon dioxide. What is the preparation of carbon dioxide? All of you know about that. Carbon on react with the oxygen, bonds with the oxygen. Carbons on bonds with the oxygen to form carbon dioxide. This is a simple equation. Carbon bonds with oxygen to form carbon dioxide. Here I have delta H value. delta H value having, that is minus 394 Kelvin. Delta H value is equal to minus 394 Kelvin, kilojoules per mole inverse, kilojoules per mole inverse. This is the delta H value. Next, about calcium carbonate undergoes decomposition and heating, undergoes decomposition. We get this, one of the calcium combines with oxygen. This calcium combines oxygen to form calcium oxide. Calcium oxide. What's the remaining product here? Carbon dioxide, CO2. Okay? Carbon and CO3 having, one of the oxygen combines with the calcium to form calcium oxide. The remaining one is CO2. Then this is a preparation of carbon dioxide. The next one is laboratory preparation of carbon dioxide. Laboratory preparation. For that we are using calcium carbonate. What is the formula for calcium carbonate? CaCO3. Calcium carbonate on react with hydrochloric acid. Formula for hydrochloric acid? HCl. Here this calcium combines with the chlorine. Calcium combines with the chlorine. What is the product obtained? CaCl2. CaCl2. And also here carbon is having, carbon dioxide is what? That is CO2. Hydrogen is having, hydrogen combines with an oxygen to form water. Then how can we balance the equation? Here having 2 chlorine is there, so make it 2 here. 2 hydrogen, hydrogen. Now the equation is balanced. Equation is balanced. Next one, what are the properties? What are the properties of carbon dioxide? What are the properties? Physical properties. What are the physical properties of carbon dioxide? It is a colorless, non-flammable gas. Carbon dioxide is a colorless and non-flammable. Non-flammable gas. It is heavier than air. That's the first point. It is a colorless and non-flammable gas. It is heavier than air. Its critical temperature is 31 degrees Celsius. Critical temperature. Next about, it is readily liquefied. It is readily liquefied. What are the physical properties of carbon dioxide? Colorless and non-flammable. It is heavier than air. Its critical temperature is 31 degrees Celsius and it's a easily liquefied gas. Okay. Then about the chemical properties. What are the first one? Chemical properties. Carbon dioxide, it is a very stable compound. It is a stable compound. This is what? It is a stable compound. Carbon dioxide on heating at a low temperature and also heating at a high temperature. First of all, carbon dioxide on heating at the low temperature. Low temperature, that is we get carbon monoxide and half oxygen, O2. This on heating we get carbon dioxide, on heating we get carbon monoxide and oxygen. Next one at high temperature, carbon dioxide on heating at high temperature we get carbon plus oxygen. Okay, can you write? Carbon dioxide on heating at low temperature we get carbon monoxide and oxygen. At high temperature we get carbon plus oxygen. One of the very important oxidizing behavior. It is a strong oxidizing agent. Carbon dioxide is a strong oxidizing agent. One of the very good example is carbon dioxide on react with magnesium metal. We get this magnesium on combines with oxygen. This magnesium on combines with oxygen to form magnesium oxide, and also we get carbon is going out. Carbon. Then how can you balance the equation? Here having 2 oxygen, so make it 2 here. How much magnesium is there? 2 magnesium. Carbon, single. Now the equation is balanced. Can you write this equation? It's a very, very, very important question. Write the oxidizing agent reactions of carbon dioxide with magnesium. It's a question. Carbon dioxide on react with the magnesium metal to form magnesium oxide, and also the carbon is leaving out. Next one, water gas equilibrium. What's the next one? Water gas equilibrium. That is carbon dioxide on react with hydrogen. Carbon dioxide on react with hydrogen. Here the carbon dioxide on react with hydrogen to form carbon monoxide. That is hydrogen combines with O. Carbon monoxide plus water. This we are saying water gas. What is water gas? A mixture of carbon monoxide and water is called water gas. A mixture of carbon monoxide and water is called water gas. So very important, one of the important questions. Next about acidic behavior. Carbon dioxide acidic behavior. Carbon dioxide and react with water. Here we get oxygen combines to carbon dioxide to form H2 CO3. What's the name of this compound? Carbonic acid. Carbonic acid. H2CO3. This one again undergoes dissociation to form H plus HCO3 minus ion. This is also both forward and backward reaction, equilibrium reaction, interconvertible, and also this carbonic acid undergoes equilibrium reaction to form H plus ion and bicarbonate ion. It's a very, very important question. Acidic behavior, and also this question also very, very important. The 2 questions also very, very important question. Acidic behavior. Next about the structure of carbon dioxide. Structure of carbon dioxide. Carbon dioxide has a linear structure. Linear structure with equal bond distance. With equal bond distance between carbon and oxygen. Linear structure with equal bond distance for both carbon and oxygen bond. Second one, this molecule there is two carbon oxygen sigma bond. 2 carbon oxygen sigma bond. The third point is there is a 3C4 electron, that is 3 center 4 electron bonding covering all the 3 atoms. Bonding covering all the 3 atoms. This I will explain after the carbon dioxide diagram. I will explain. 3 center 4 electron. First one is it has a linear structure with equal bond distance of carbon and oxygen bond. 2 carbon oxygen sigma bond and 3 center, 4 electron bond covering all the 3 atoms. Let us discuss how to draw the structure of carbon dioxide. How to draw. First one, carbon dioxide having 3 elements. What are the 3 elements having? Oxygen, carbon, oxygen. Okay? Oxygen, carbon, oxygen. What is the atomic number of carbon? Atomic number of carbon is 6. First shell is a K shell. We can be accommodate 2 electrons. Second shell is 4 electrons. Next element is oxygen. The atomic number is 8. First shell is we can be accommodate K shell 2 electrons. Second shell 6 electrons. So as per this order we can be accommodated here. Oxygen having outermost having 6 electrons. That 6 electrons must be accommodated here. 1, 2, 3, 4, 5, 6. This oxygen gained electron, so make the negative charge here. Carbon is a tetravalency. Carbon is surrounded by 4 bonds, so tetravalency. Now have only 2 bonds, make it triple bond here. Triple bond. Here, oxygen atom is gaining electron, so 2 electrons. This is the first step. Second step. The second step when you are drawing, the electron will be attached here, so the single bond is converted into double bond. Single bond is converted into double bond. Here having triple bond, will be electrons will be goes to oxygen, so triple bond is converted into double bond. So oxygen, double bond, carbon, double bond, oxygen. Now here electron pair goes to here, so 6 atom having it is converted into 4 atoms. Here having 2 atoms, it is converted into also 4 atoms. Here electrons jumping. Okay. The next one. Electrons here 4 electrons goes to attachment here, so the double bond is converted into triple bond. Here the double bond having electron goes to oxygen to form single bond. Now we can draw oxygen 4 is converted to 2 electrons, triple bond, double bond is converted to triple bond, carbon, single bond, oxygen with 6 atom, and gain of electrons to get a positive charge. With the gain of electron, you get negative charge. Gain of electron with negative charge. Here is the donate electron, positive charge. This is the structure of carbon dioxide. I told you it have the third point, structure of carbon dioxide, third point, 3 center, 4 electron bond covering all the 3 atoms. All the 3 atoms. They have 3 center. 1, 2, 3. 3 center having. Here having electron 3 bond pair. 1, 1. Here 4 electron bond. That is 1, 2, 3, 4. Here also 1, 2, 3, 4. 1, 2, 3, 4. This is the 3 center means 3 element having center, 4 electrons. 1, 2, 3, 4. This is the structure of carbon dioxide. For the easy remember, this is one of the structure of carbon dioxide, the second one and the third one. First oxygen having 6 electrons. Here the second one having 4 electrons. First. Next, third one having the 2 electrons. So first one 6, second one 4, next one 2 electrons. From the back side, here first one 2, the second one 4, the third one 6. So make it clear. Okay. Next about the uses. What are the uses of carbon dioxide? First one, Carbon dioxide is used to produce an inert atmosphere for chemical processing. For chemical uses of carbon dioxide, it is used for chemical processing. Chemical processing. The second one important, very, very important use. Biologically, it is used for photosynthesis. Carbon dioxide is used for photosynthesis. The third one, it is used in fire extinguisher. Fire extinguisher. Then one more point, it is used as a propellant gas. Propellant gas. These are the, at least you should be learned any 3 points for the 3-mark question. First one, it is used to produce an inert atmosphere for chemical processing. In biologically, it is an importance for photosynthesis. It is used as in fire extinguisher and also propellant gas. Now all of you take your textbook. We can mark the book bag question, few book bag question, already some we mark. Page number 54, page number 54, question number 5. You write a short note on, write a note on Fischer top synthesis. It's one of the important question, repeating question. Question number 5, the answer, page number 44. All of you take page number 44. Today first question. Page number 44, top of the page. The answer, the reactions of carbon monoxide with hydrogen at a pressure of less than 50 atmosphere using metal catalyst at 500 to 700 Kelvin yields saturated and unsaturated hydrocarbons. With the two equation, what are the two equation? N moles of carbon monoxide plus 2n plus 1 hydrogen gives CnH2n plus 2 plus n moles of water. Next one, n moles of carbon monoxide plus 2n moles of hydrogen gives alkenes plus n moles of water. That much. The next question, page number 55, the next question is fifth question. Give the structure of carbon monoxide and carbon dioxide. Page number 44 and 45. In the middle of the page, a structure having, you should be select at least 3 points. It has a linear structure. In carbon monoxide, 3 electron pairs are shared between carbon and oxygen. This bond can be explained by molecular orbital theory. The carbon-oxygen bond distance is 1.128 angstrom. That any 3 or 4 points is enough, including the structure. Then about the carbon dioxide, page number 45. Structure of carbon dioxide. That also any 3 points is enough. Carbon dioxide has a linear structure with equal bond distance for the both carbon and oxygen bond. In this molecule, there is a 2 carbon-oxygen sigma bond. In addition, there is 3 center 4 electron bond covering all the 3 atoms, including the diagram. The next question, later I will tell you. The 8th question, describe the structure of diborane, already marked, page number 37. Diborane 37, page number. Structure of diborane, the page number 37. This is only for 3 mark, some few points is enough and including the diagram. Structure of diborane, already we marked that one. And next one, write a short note on hydroboration, this also marked, page number 37. hydroboration. Top of the page number 37. Diboron adds to an alkene and alkynes in either solvent at room temperature. This reaction is called diboron. That is enough. Then about the equation. B2H6 plus 6R CH double bond CHR gives 2R CH2 bond CHR3B. Next about give one examples for each of the following: icosagen, tetragen, pictogen and chalcogen. First one is a boron family. Boron. Second one, carbon. Third one, nitrogen. And the fourth one, oxygen. Next question. Write a note on metallic nature of P block element. 11th question. Write a note on metallic nature of P block element. Page number 28 and 29. 28 and 29. The middle of the page having metallic nature. The tendency of an element to form a cation by losing electron is known as electropositive or metallic character. The character depends on the ionization energy. Generally, on descending of a group, the ionization energy decreases and hence the metallic character increases. And also including the next page, 29, page number 29. In P block, the element present in lower left part are metal, while the elements in the upper part are non-metals. That also marked. That much is enough. Next about that question number 12. Complete the following reactions. A already we discussed. B also. C, D, E, F, G and H I will tell you the next class. I and J already we discussed. Please do it. This is a assignment work for today. If you have any doubt, please call me. I will help you. G and H I will tell you tomorrow. The next one, question number 13, the very important repeating board exam question. How will you identify borate radicals? The page number is 35. Page number 35. Middle of the page, ethyl borate test. When boric acid or borate salt is heated with ethyl alcohol, the presence of concentrated sulfuric acid and ester triethyl borate is formed. The vapor of this ester burns with a green edged flame, and this reaction is used to identify the presence of borate. H3BO3 plus 3C2H5OH gives concentrated sulfuric acid. We get triethyl borate plus water. It's a very important question. Next, question number 14 I will tell you later. The question number 15. How will you convert boric acid to boron nitride? How will you convert boric acid to boron nitride? Page number 35. They're having the actions of ammonia. Fusion of urea with boric acid in an atmosphere of ammonia at 800 to 1200 Kelvin gives boron nitride. First one, boric acid plus ammonia gives boron nitride plus water. That's the answer. Page number 35. Okay. Today assignment. Page number 55, question number 12. Page number 55, question number 12. Complete the following reactions. The following reactions. Thank you all of you. Thank you. Have a nice day.